Hello friends, welcome to my channel Book to Brain. So today I'm solving one of the problem from finite element method, which is we generally call FEM. So this problem is based on axisymmetric loading. Okay, let's start with the problem. So a long cylinder of inside diameter 80 mm and outside diameter 12 mm snugly fits in a hole over its full length. The cylinder is then subjected to an internal pressure of 2 megapascals. Using two elements on the 10 mm length as shown in the figure, the displacements at the thinner radius we have to find. Okay, so this is the given sketch for the given definition. Okay, so I'll simplify this one, the sketch, so that we can understand better. And this sketch, either they may give in the exam or sometimes they may skip and they may give only this definition, or else in some question paper what they will do is they will give like this: determine the B matrix relating element strain to nodal displacements. Okay, so for the axisymmetric formulation, and they will be giving this sketch they will give, and they will give this definition. So you have to solve this problem. So let's go for the next step. So see, node 1, node 2, node 3, node 4. So they have made it two part, that is 1 and 2. Okay, so first part we will take this 1 2 4, and next part we will consider 2 3 4, one element, second element. Okay, so say element connectivity table. So here is the element connectivity table. Let's see here. So connectivity and element, there are two elements, 1 and 2, connectivity 1 2 3. We will consider first 1 2 3 node, that is, see, 1 2 3 means here for element 1, connectivity 1 2 4. Okay, 1 2 4 4. Okay, so at that time the coordinates for node 1, these are the nodes and these are the coordinates r and z. And remember that in this problem, in axisymmetric problem, there is no y-axis or something. Z and radius only matters. The theoretical portion which is required for this derivation I will upload in the next video, or along with this video. Okay, or else if you can refer any other textbook, then you can go for it. So in axisymmetric loading, z and r, radius and axis z only will be considered. So here node 1, r is 40. So here we'll see r, radius is 40 for node 1. This distance is 40, that is, it is 40 mm away from z. So and z, the length, the distance from point, that is 10. See here, this is 10 mm, this is 10 mm. Okay, distance. So node 2 is same, from z axis it is at a distance of 40 mm, and the length is 0. Okay, sorry, for node 2, yes, 0. For node 1 it is 10, and node 3 60, distance is 60. See here, same sketch, 60 node 3. For node 4, that is also 60, and z value, where is z, is 0 for node 3, and for 4 it is 10. Okay, so next, so these are the forces at, see here, the forces acting at node 1 and node 3 they have mentioned, because in the next step I'll tell you why it is 1 and 3. Okay, so the equation is 2 pi r1 into L into Pi, that is pressure. So L is a Z here. Z, okay, L is same as Z, and R1 is this 40. Okay, so next D matrix, we'll check. This is the equation for D matrix. D is equal to E Young's modulus into 1 minus percent ratio it is. Okay, so continue this equation, and this is equation for this one. And in this axisymmetric loading, only plane strain exists. Okay, there is no plane stress because of the axis. So here only plane strain exists. That is why this is the equation for D matrix D. Okay, so we have E value, we have Poisson's ratio, this one we have all this one. So we'll substitute, and this is D matrix. Okay, D matrix is same for element 1 and D matrix is same for element 2 as well. Okay, okay, see, I have taken 2.69 into 10 to the power 5 inside. Okay, I have taken this inside. So this is next after taking it in. So next up we know that G, Jacobian, this one, you know it, J equal to R14 Z14 R24 Z24. This is the derivation part, and you can refer derivation to understand what it is and how it comes. So as usual, R14 is R1 minus R4, and these values are in table R1 R4, all values substitute, and you'll get this one. So let and get J. So after that, the area of the triangle. Okay, and this one R1 is R1 plus R2 plus R4, that is radius. R1 why I have written, because see this is confusing. R1 is for element 1. Okay, this is R1, this R1 means for element 1 the value R is R1 plus R2 plus R4 divided by 3, that is 46.67 millimeter, and Z as well same. Next, B matrix for element 1. This is B matrix for element 1. Look at this matrix. Okay, and here how this 2 4 4 1 Z1 2 comes means, see, now we are considering this portion 1 2 4 element 1, this portion we are considering. So remember that for that 1 2 4, and for Z 8.1 here, 1 hold 1 constant, 2 into 4. Okay, next hold 2 as it is, next 4 and 1, next hold 4 as it is, next comes 1 into 2. Okay, this is clockwise direction for Z, and R, that is counterclockwise direction. So here 1 hold 1 constant, 4 and 2, next hold 4 constant, 2, sorry, first hold 1 constant, that is 4 and 2, next hold 2 constant, that is this side 1 4 you'll get, next hold 4 constant, that is 1 2 and 1 you'll get. Okay, fine. Next is, yeah, we'll find out values for Z24 Z41 Z12 R42 R14 R21. Okay, so here we can see them. Z24 is Z2 minus Z4, that is these values R4 R2 Z4 Z2 and all are in the table. Okay, just refer that and substitute here. See, here Z24, that is minus 10 we have, so divided by J is 200. So similarly substitute for all, and at the end you'll get B1 is like this, you'll get B1 like this. Okay, next for element 2 same. Now for element 2, earlier it was 1 2 4, now it is 2 3 4. Earlier it was 1 2 4 for element 1, now it is element 2. You'll have element 2 2 3 4. Okay, 2 3 4. So 2 3 4. Well, see, so now this also changes accordingly. So now it is clockwise for z, hold 2 3 4. Next hold 3, it is 4 2. Hold 4, it is 2 3. Similarly for this r value, hold 2 counterclockwise we have to check, hold 2 4 3, hold 3 alternative this one. Okay, now held 2 4 3. Now hold 3, because we have to check from counterclockwise for r. So hold 3, that is 2 4. Next hold 4, that is 3 2. Okay, you'll understand that when you solve this. Okay, similarly, similar to b1, you have to calculate b2 as well. Okay, this is a step for b2. And after getting b1 and b2, and I'll show you the final equation first. So our final equation is for axisymmetric triangular 2D element stiffness matrix k is equal to b transpose into d into b into 2 pi r e. Okay, this is our final equation. So now we have b value, d value, that is there are two b value, b1 and b2, and only one d value. So now yes, b1 b2 value we have. So now to get this b into d, we will start multiplying d and matrix d into matrix b. So here d into b1 first I'll consider. This is d value, okay, and this is b value, b1 value. Yes, b1 value. Okay, so we'll multiply, and you know it, this is 4 row and 4 columns, and this is having 4 rows and 6 columns. So 4 into 4, that is matrix, this is 4 into 6 matrix, this one. So you'll get 6 into 6 matrix. Okay, sorry, 4 into 6 matrix. Okay, 4 into 6 matrix we will get. So multiplication method is this one is like this, and this one to get this value, this multiplied by this one. Okay, this row, this column, you'll get this value, and first row, second column, you'll get this point, like this, first row, third column. So first row, this row 1, column 3 value you will get. Similarly row, this one, row side, and fourth one, fourth column, you'll get this value. First row, fifth column, you'll get this value. First row, sixth column, you'll get this value. And to get this one, second row, first column, this value. Second row, second column, this one. Second row, third column, third point. Similarly 4 5 6. Next here, to get this one, third row, first column, first value. Third row, second column, second, like that. For fourth also same, fourth row, first column, this value. Fourth row, second column, this value. Similarly you have to carry out this one. Similar to b1, you have to calculate db2. This is d value, this is b2 value. Multiply this similar to that method, db1 method. Similarly you have to multiply this. Okay, so you'll get this table. So now we have d, so this is the equation, we have d value, we have b value. Okay, so now db multiplication is done. Now we have to transpose the b. Okay, this is the b transpose. Here b1 is for first element, b1, d is as usual, db we have multiplied 2 pi r a. I'll tell you which is this. So now we'll transpose b1, we'll get, wait, so it's b1, yeah, Here it is b1, we'll transpose it. So minus 5, sorry, minus 0.05, 0. The row is written in columns while you transpose it. See, this is b1 matrix, so row is written in terms of column. Okay, so earlier it was 4 rows, now it is 6 rows and 4 column. Okay, and this is b transpose, and db value you have, so put it here. And before that I'll show you this. So 2 pi r1 into a1, so 2 pi into r1 is 46.67. this it. Okay, so I have shown you r1 is 46.67, j is 200, and area is here. Okay, sorry, area must be 100. 1 second, this is not 1 by 2, this is actually j by 2. Okay, that is 200 by 2, this is 100, this is area is 100 millimeter square. Okay, I did not check it actually, so this is the correct one. So you have 2 pi into 46.67 into a is 100. So after solving you'll end up with this value for this portion. Okay, this 2 pi into r1 into a. So here there is 10 to the power 4, and here this is the part of this equation, so 10 to the power 5. So 10 to the power 4 plus 10 to the power 5 is 10 to the power 9. What I have done is in this problem I have considered, so 10 to the power 5 plus into 10 to the power 4, that is 10 to the power 9. So but 10 to the power 2 I have considered inside, or I have taken inside, and 10 to the power 7 only I kept it out. Okay, so this is 10 to the power 7, so that I can avoid fractions and I could get better answer here. So I took 10 to the power 2 inside. You can do in your own method in a different way. So after solving this, this is b transpose into db, this is b1 transpose into db. Okay, so and this value 2.93 into 10 to the power 4 also included along with this. So I'll get this answer later. After solving I'll get this answer. Multiplying, how you have to multiply, you know it, a row into column. To get first value, this row first column, to get this one first row second column, like that this also. So here is the value, and this is axisymmetric problem, and this portion is symmetric. Similarly, okay, symmetric. And similarly for element 2 as well, here this is b matrix 2, second, for second element, d into b matrix for second, this is transpose, and this is b matrix b2, and this is 2 pi r2. Here r2 value changes, remember that, because see here this one, what, r2 r3 r4. Okay, r2 r3 r4, earlier r1 r2 r4 for b1, for b2 this is r2 r3 r4, so radius also changes. Fine. So similar to this one, I have considered 10 to the power 7. So 10 to the power 2 I have taken inside and multiplied, so I'll get these values I have received. And same, this is axisymmetric problem, so these terms are symmetric. And after that, so using boundary conditions, what is the boundary condition? Let us see k into q is equal to f. Okay, so boundary condition, see, element 1 q1 q2 q3 q4 q5 q6 q7 q8, here. Element 1, this side it can take sliding, that is 1, this is q1, okay, and this is q3, so this can slide this way, so there is no restriction. So here one displacement for 1 and 3 is allowed, and for any other element there is no displacement. So what it will happen is, see, q1 is having displacement, q3 is having displacement, and this is the force calculation I have shown you. So how you have to calculate the force? So that is why force I said f1 equal to f3. What happened? This is f1, f3 is equal to equation I have given, because there is only possibility to have sliding motion or displacement is in this direction 1 and 3. That is why we have considered only f1 and f3. So next is substitute here. 1 2 3 4 7 8. 1 2 3 4 7 8 first element. For second element 3 4 5 6 7 8 for second element 3 4 5 6 7 8. Okay, so by applying boundary condition and elimination method, what we will get is this one. Elimination method, I think you are aware of it. So 3 and 1 are only available. This will be 0 or eliminated. This portion is eliminated. This portion eliminates. This is eliminated. Similarly for this also, 3 is available. 4 5 6 7 8, these are eliminated, so 3 is available here. 3 and 3, here there is 1 3 3, so you have to add this value, you'll get these values, and since it is symmetric, you get same. So after this thing, using the calculator, solve this q1 and q3 value, and these are the two displacement values, q1 and q3. Thank you.